Hey friends, it's Ben again with yet another in my thrilling series of documentary videos on the math tech class. Mm. Uh, this particular video is to help you all out with the day 4 stuff. What we're looking at is the idea of scatter plots and linear regression. And I'm realizing that probably I should show you a picture immediately. Let me pause and find something. Okay, sorry if there's a little skip right there. I went and did a quick search online to find an example that would let us see the sort of things that we're talking about. So let me share screen here, hopefully. Yeah, all right. So this is an example that has it done with Python. Later on, we're going to learn how to do some stuff with Python. So, I figured this isn't too bad an example to bring up there. So you see all those red dots that are appearing there? Those are representing some sort of data. Does this particular one have information? It's actual versus predicted values from the dummy data set. So yeah, it's just crap stuff, okay? But oftentimes you'll collect two pieces of data from one individual, maybe their height and their weight. Maybe you're talking about a car and you get its age and its asking price. That's an example we're going to look at in a minute. Or maybe it's the displacement, the number of liters in the engine as compared to the miles per gallon that you get for it. Just as examples there. So if you use one of those that you think is explaining the other as the X value, and the one that's being explained as the Y value, displacement on the car being the X, and then the miles per gallon being the Y, that's just a quick example there. You can plot a bunch of points like this on the XY plane. If those points seem like they're more or less line shaped, so this example here is something that's more or less linear, then it makes sense to develop a model like a linear model y equals mx plus b, where m is the slope and b is the intercept. And just try to get the thing that fits the best in there. Now, this particular diagram gives you a little bit of help showing what's going on with it. And that is that the SSD that they have there is the difference between an actual data point and the predicted value that comes from the line if you have that X value, okay? And what we're actually doing when we set up one of these linear regression lines is finding a line so that the total amount from all the data points is going to be having the minimum total error, okay? They say things about the line of best fit, the least squared error. Those are the sorts of phrases that you'll hear on that, okay? Now, we're not going to have to know a bunch about the theory, and we're certainly not going to have to do this by hand, okay? But the thing that's going on is that you are taking and getting out as your answer these two variables, or later we'll look at an example where it's more than two variables, but these two variables that give you a way to predict values given an X, what the Y is going to be, okay? We refer to it as linear regression, and we usually look at straight lines, but the linear actually refers to the method, not really to what we're trying to fit to it. You can just as easily fit parabolas and exponentials and any other kind of function that you want to with this. And we're going to look at it on Excel, which has all that stuff built in. It can just do it. It's pretty slick. So in any case, though, we're going to look at some examples here, and I'm going to launch right into them, okay? And so, oh, well, actually, yeah, I'm sorry, before I launch into them, I'm going to show y'all a couple of pictures real quick here. First one is a screenshot And the reason I'm showing you this screenshot is I'm not sure whether you will be able to see the menus. See, because sometimes when you're using an app and it creates a new window, it doesn't always show it in the shared window that we've got for Zoom. And there's nothing I can do to fix that except for change back and forth 50 different times there between the things that I'm showing you. So if you look here, this is what I'm referring to when I say something about the regression tool choice. So you go into your menu and look at the tools menu and pull down to where it says data analysis. And from that menu, you're going to get this pop-up dialog box where you will choose regression. Linear regression is what we refer to here. Okay. And so I'm going to hit stop share on that. And then let me go ahead and close that one. Oh my. Now this is going to be super annoying because it does not know which thing to close. Great. Okay. Sorry. So let me share then a picture of what the menu will be that comes up after that. And that's the same thing. So maybe I can go to that. Okay. All right. So this one here, if you can read it, says something about an input Y range and an input X range. And the thing that you're going to do is to click on the little box to the side of those, and then you're going to highlight a certain range, okay? And the Y range is going to be the things you're trying to predict, and the X range is going to be the variables that you're using to predict them with, okay? So I'm going to hit stop share on that, and I'm going to quit out one of the mini programs I'm running. All right, so let's go ahead and now launch into it. So, okay, so looking here, this first example of what we're looking at, we have some data, maybe it's taken from a newspaper or something, that there's several different Honda Civic LX sedans that have been offered for sale in the newspaper. Two of them were 1 year old and had prices of $17,850 and $18,000 because not every car is going to be exactly the same offering price. There were three of them that were 2 years old and they have various prices, a couple of 3-year-olds, 4-year-olds, and so forth. All right. So what we think is that the age of the Honda Civic LX sedan is the main contributing factor in what the price is going to be, okay? And so we're going to develop this model y equals mx from that. So in doing this, one of the first things to do is to take a look at a scatter plot and see whether this makes sense. So to get a scatter plot going, all I do is to highlight variables. As a matter of fact, I forgot to highlight, if you include the age and asking price on there, it will magically figure out how to put those into the appropriate labels and stuff. So we want to go to the insert menu, and that's completely wrong. Sorry. We want to go to the insert ribbon. So you see across the top there where it's got pivot table and stuff like that. It's referred to as a ribbon, unless they've changed the name on me again. So we're looking here. I think you can see that I've got my hover is showing XY parentheses scatter. And I am going to click on that, and I've got a bunch of choices there. Now, listen to me, because I have taught the same material a million times and people never listen at this point. You see how you got 5 choices across the top? You want the one with no lines between it. If you choose one that has the lines between it, it's wrong, and you'll just get it wrong. and that will just be that, okay? So we want the one in the upper left, and we plot that, and we can see that it's telling us, oh, it didn't label it like I wanted to. Oh well. But it shows these points going kind of more or less in a straight line going down. And if you go to any one of them and right click, the pop-up menu should give you the option of add trend line. So I'm going to add a trend line. Hopefully you can see the menu that came up with that. It doesn't seem like it, it seems like it was a pop-up, not an entirely new window. But in that, you should be able to see right here that it shows linear as the option we've got. If you were in another class needing to do something with an exponential, logarithmic, or whatever sort of fit, those are all options that are built into Excel. Then going down here at the bottom, there's an option that says display equation on chart and display R squared value on the chart, okay? So we're going to go ahead and tell it to do both of those. And now I'm going to close out that little inset menu there. And you can probably see these, but you probably can't read them on your screen unless you zoom in. But it has y equals negative 1412.2 times x. That's going to be our m. And 19198, and that's going to be our b. Okay. So we can go ahead and do things with those from there, but I want to show you another way that you can get these. Kind of remember those values, because now we're going to go ahead and use the data analysis tool. So if you go up to Tools, which is on the menu at the top of the screen, I got to tell you, I don't know where it'll be on Windows. Look for a menu that says Tools, though. And you go down here a ways, it will have data analysis as a choice. Okay. Now here's the point at which I don't know whether you can see the pop-up window or not. So, but you need to choose where it says regression on that pop-up menu, or dialog box, or whatever you want to call it, and tell it okay. And it will bring up another dialog box. And in this dialog box, you have a couple of choices that say input Y range and input X range. Y range is the things you're trying to predict, the price. X range is what you think explains them, and that's the age. So I'm going to click on the little box that's got a red arrow in the middle of it, and it lets me go highlight these prices. And you have to highlight all of the prices and nothing extra. If you screw up where you click on, you'll get the wrong number, and I can't help you. That's just a matter of pointing the right place. The next one is the X values, and that's the age. And so I'm going to highlight those, and then I'm going to click on the little box again, and now those things are filled in there. I am going to turn off all of the options, because the things that it will say in the menu about residuals and normal probability, they're just kind of outside the scope of what we're going to actually do with this. Okay, just hit OK, and it went ahead and put my output here. Now I should have chosen a different spot for it to put the output, because this looks like it could have accidentally like overlapped into something else. But fortunately, the asking price plot didn't get covered up. So, all right, so it's got a bunch of stuff here. Remember that R squared that we got in the graph of 0.9053? If you spot here, that's appearing in the same, in this sort of output as well. This means that if what you need is the R squared value, you could actually use just the data analysis tool, and you don't have to use that graph to get it at all. The reason I always do the graph is that I need to look and see, does it make sense? Did those things look like they lined up? If the R square value is close to 1, that means they're lining up pretty good. Okay. Now, underneath that, it will have, actually it's above that, it has multiple R value, okay? So when we talk about R squared, it's actually going to be a number between 0 and 1, but it comes from a value R that goes from -1 to +1. And the closer you are to either -1 or +1, the better things lined up. However, if you square it, then you don't have to deal with negatives. And so you can just talk about if it's close to 0, then it doesn't line up good. If it's close to 1, then it lines up well. The thing is that with these R values being possibly negative, anytime the slope of the line that's lining up there is negative, the R value should be negative. So this annoys me that the R value that we ended up here doesn't have a negative on it. It means that the way that the computer got R was to just take a square root of the R squared, which there's a better way to do it, but I don't know. All right, so notice also from our graph, the slope of our line was -1412.2. What that means is, roughly speaking, your Honda Civic LX sedan loses about $1,412.20 in value every year, okay? But if we look down here, that -1412.2 appears under coefficients of the X variable, and it in particular said X variable 1 there. I'm surprised it did not name that as age, because it seems like it should be able to figure that out. But anyway, though, so that there, and then the intercept, the B part, is this 19,198.32 something. So in theory, what this should mean is that the new asking price for a, in other words, the 0-year-old Honda Civic LX sedan should be $19,198.32. It's not. You know, these are all estimations based on some data that we have. But anyway, from that data there, what we're going to do is to name these. Here, the -1412, I'm going to go ahead and go up to that cell name and change that to be Honda M. Okay. And then I'm going to take the intercept and I'm going to name it Honda B. Okay. The reason I want to do that is I'm going to come up here to the price and I'm going to get estimates for a 3-year-old, 5-year-old, 7-year-old car. And I'm going to say equals to tell it that I'm going to do a formula. Let's see if I make that bigger. But equals, and we're going to say the Honda B plus the Honda M times, and now I'm going to click on that 3 up there so that it's positional and hit enter. And now it's predicted 14,961.63, blah, blah, blah. Okay, I'm going to format that like we do money. So I have to go to format and cells, and I'll say currency, and we'll do 2 decimal places and have $1. Yeah, that'll take care of it. I'll hit OK. So see how that formatted it all nicely there? Now I'm going to take and get my little black handle there in the lower right-hand corner and just drag across and tell it to do the other 2 car prices. All right. So the prediction for a 3-year-old car is 14,962. For a 5-year-old is 12,137. For a 7-year-old is 9,312. Yeah, you know, so it's getting those estimates there. That's what you're looking to do on this. Okay. And so that's it for these. Now we're going to go and look at the example with home prices, right? And if I zoom in here, you can read that it's for some community called Mount Pleasant. I totally stole this example out of a stat text. They had a bunch of data online for bunches of different communities. I don't know if it was real or made up data, but anyway, I stole some data. But we're going to do the same sort of thing here, right? First thing I'm going to do is to highlight the data, and like so. And I went ahead and included the title at the top to see whether I could get it to insert on my scatter plot the title. And it did something I did not expect. It gave me a bunch of numbers down below and stuff. I think maybe that I shouldn't have highlighted that title. Well, this is one of those, I think I used this joke with you all the other day. You get to learn from my mistakes. And if you're learning from my mistakes, you get a chance to learn a lot, because I make a lot of mistakes. All right, let me try it again. Insert XY plot. Okay. Now, if you want to, for that chart title, you can just say home prices. Home prices. All right. Oop, I don't need to enter there. Oh man, so sloppy. All right. So taking a look at that, it looks more or less linear. Okay. But with regard to that, I'm going to take and set that over there. And I'm not even going to bother with right-clicking and getting a trend line. I'm going to go straight in here and tell it to do my tools, data analysis, regression, okay. And now I have to tell it which is the Y range and which is the X range. So if you can just look at them and see what they are, you could just type those, but I'm going to have to click and then drag over them. So I drag from bottom to top, because if I don't, sometimes I miss some of them. But remember, you have to then click to tell it you're done with that. Now I'm going to do the X ones, and that's, remember, we're thinking that the square footage for a house is going to determine what the price is. So I am putting that in there. And remember, you must not highlight anything else beyond what data you're using. And you must not miss any of the ones that you need to highlight. All right, and then I'm going to, for output range, I'm going to choose a position here that looks like it's not going to overlap anything. And then I tell it okay, and just boom, it provides me a bunch of answers. Now, from having done this before, we know the coefficients for the X variable and the intercept there are going to be the numbers that we want. And then we'll also take a look here at our R and our R squared values. Notice this time our R squared's like 0.52-ish, right? So that's not a really strong correlation. But I have read some textbook authors say sometimes it's not really so much about whether the number is close to 1, but rather whether it's a useful model. And so, yeah. If you do some Googling and find out about strong positive and strong negative correlations, it would be pretty cool for you to write up something about that in your progress report for the day. All right, I'm going to come down here to where that X variable coefficient is, and I'm going to rename that home. Do you remember whether it's the M or the B? It's going to be the M because it's the slope of the line. And then here for the intercept, that's going to be the home B. Okay. Now, Up here, there's a place where it has price per square foot, and that's going to be the M, because it's what you multiply by the square footage. Hi, Arthur. Would you like to say hello in my video? Apparently, he wants to play with his toys. Okay. So anyway, the price per square foot is going to be the home M. Because if you have one more square foot, then you expect for that to be how much that the price goes up by. And I'm going to go ahead and do my formatting for that real quick. And so how do I do that? Right click on it, format cells. Oh, it says Command 1 is a shortcut. But currency, 2 digits past the decimal. I kind of like to have a comma in there if it's bigger than 1,000, but you know. All right, now for our price, you have to remember it's equals to start a formula, and then it's going to be, because we're doing the homes, home B, oh, I should make that bigger, home B plus home M times the number that we've got up there, the 3328, and I hit enter. And then I'm going to go ahead and do the formatting. Oh, I think I'll go ahead and hit the Command 1 this time and skip straight in. It's currency. So I'm going to actually put no digits past the decimal, because you don't put dollars and cents. You don't put cents on when you talk about houses. Okay. So this is saying a 3,000 square foot house in Mount Pleasant, well, 3328. You're expecting a sale price of 657,723. I'm not a real estate guy, so I don't know if that makes sense or not. All right, I'm going to copy that, and I'm going to paste it to 2 locations, and you're going to remember that this whole thing is positional. Okay, I have a screaming child. I'll be back in a second. And as soon as I stop my video, he stopped screaming. So, all right. So going back to where we were at here, you have on that all the stuff we're looking for. All right. I think one of these sets of instructions I told you to highlight some stuff and change the color in the background. Read the instructions and see which one that is. Okay. There is another tip in here to look at. Yeah. So remember when I said something about the R squared tells you how well things line up? There's also another piece of information here that's referred to as significance. Do you remember on the previous assignment when we did something with the p-values, and a small value for p tells you that something is a significant result? Well, this here, we ended up with a significance, a p-value for something called an f-test, which is, if you can read it there, oh, I should make it bigger. I'll make it bigger. 5.25 times 10 to the negative 9th. That is to say, if you wrote it in decimals and not scientific notation, it would be 0.00000000525. That's way smaller than 1%. So that says this result probably is a pretty good predictor. Okay. All right, then we're going to take a look at another one here, and this is doing something with Kia. I've got an old car sitting in my driveway that's a Kia Soul, so it's a fairly popular model to be out on the road. They're cheap cars, but they last pretty good. So anyway, taking a look at what we've got here, we're going to use displacement of an engine to predict highway miles or to predict city miles, okay? Miles per gallon, that is. So I'm going to do one in particular here. I'm going to pick a model, And I want you to pick a different model. I don't really care which one it is, just you should pick a different one so that you can make sure that you're seeing uh, uh, how to do something and that you're not just copying exactly what I do. So I'm going to do the Borrego two-wheel drive, and maybe y'all could do the Forte or something. I don't know. So I'm looking across here with the Borrego. And if you notice, it has options for rear-wheel drive or four-wheel drive. I'm just going to do one of those because if you know anything at all about cars, you probably know that something that's four-wheel drive tends to not get as good a mileage. Then if you notice here, I also have automatic transmissions, 5-speed and 6-speed. If you've got a lot of data points, you could narrow it down and just look at the 5 speeds or just look at the 6 speeds. I don't know, but I'm going to just do these here, all right? And so in order to keep my eye on that, I'm going to take this group here, and I'm going to highlight the background of it in blue, all right? No, that wasn't blue, that was green. I swear to you, I'm not colorblind. I just didn't pay attention to what I was doing. All right, so I highlighted those in blue, and maybe beyond that, I can go hit this button here that will put like a square around them, you know, just so I can spot where they're at. All right, so I'm going to go in here, and I'm going to do the data analysis stuff from the tools menu, data analysis, regression, and I'm going to, on this one, say that the Y values, I'm going to look at the highway miles per gallon. If you would like to do something slightly different, maybe you look at city miles per gallon, okay? And I'll hit return on that. And then the input X range, I'm going to pick out the displacement. Now this is given in liters. So if you're an old school gearhead, you're probably used to it in cubic inches, and liters are hard to think about. Then I have to tell it where to put this. I'm going to put it here at N12. Doesn't matter exactly where it's at, but hit that, tell it okay. All right, and so looking down here in my coefficients, this, I don't remember what I told y'all to call it here. So, but I'm going to call it maybe the Kia M. And then this one, I'm going to call it the Kia B. All right. I miniaturized it. Okay, so now for what I'm going to do with these predictions here, I'm going to be talking about a Borrego two-wheel drive in all these. So I'm just going to put that in there. And then the drive on those is the rear-wheel drive. So I'll put that information in there. And then the transmission on these was different between them. I'm just going to put automatic. Okay. Yeah. All right. And then here under the highway miles per gallon, I'm going to say equals, to start a formula, Kia B plus Kia M times that displacement. All right. And wow, I got a nice number there even. I wonder what that 1 was there for. All right, so I'm going to copy that and just paste it to these other 2 points here. And you'll notice that it is giving you 18.75 on this and 19.5 on that. In general, when you get miles per gallon, they always put it 1 digit past the decimal. So I'm going to highlight those, right click, tell it to format cells. Remember, you can skip and go to command 1 for that. Not sure whether you can see the dialog box that came up, but it has across the top number, alignment, font, border, fill, and protection. We want number. And then categories as general, number, currency, accounting, date, time, and stuff. We want number. And then it gives us the option of using how many decimal places. And we want to adjust it to just 1 point past the decimal. So now it'll say 21.0 and 18.8 and stuff like that. Okay. So if you're thinking about that, that really does not make any sense, because what it has come out with now is that the larger the displacement for the engine, the more miles per gallon you get. Well, crap. So that is probably because of the fact that I grouped the 5 speeds and 6 speeds together. All right. So, oh well. And I am going to take all those and take their border off and stuff. All right. So, do what you can on that. Like I say, choose something other than the Borrego 2-wheel drive. Okay. I am not looking for the exact answers you get. I'm going to look at your formulas and see whether you've actually entered stuff there. All right. Okay, so the last bit here is going to be Moneyball. I believe this was the name of a movie, like quite a few years back, but it is something that is a legitimate phenomenon in baseball. I think I got the name right, that it's called sabermetrics, after somebody who realized that there are so many damn statistics that are kept in baseball. And he realized that he could take a look at the statistics for players and predict how well they would help a team out. And so rather than spending $20 million on 1-star pitcher, I forget what team he was coaching for, but he found a lot of players who were undervalued. That is to say, they weren't big stars, but that they were doing good jobs. And he figured out that he could put together a relatively cheap team and raise the winning percentage. And so he did that, and his team did a really good job the next year. And then, like a fool, he told people his secret. And then teams that had a lot of money also did this. And so, yeah, now everybody looks at all these statistics. But so I am going to do a couple of different things here. And it just occurred to me that I do not have for you numbers in the input. So I am totally going to make some up. And let me take a look here real quick at what we're looking at. So runs scored, it seems like we're doing numbers that are somewhere between generally 600 and 800. So maybe if I said equal, okay, you don't have to pay attention to the thing I'm doing right now because it will be taken care of. As a matter of fact, I am going to stop my sharing and pause, and I'm going to fill in numbers. So just a second. Okay, so I made up some numbers. All right, so coming back to this here, we're going to try to predict the number of wins for a team based on their runs scored and runs allowed, okay? That's something that pretty much makes sense, because if you're allowing more runs than you're scoring, probably you're not going to win very many games, you know, if you're doing that consistently. So we are going to go ahead here and, as usual, go to Tools and Data Analysis and Regression. Okay, now hopefully you can see what's going on there. We want to predict the number of wins for a team. So we highlight all the wins and nothing more and nothing less. Now, this is the tricky bit. Now we're going to do the input X range using the runs scored and runs allowed. Okay, those, we're using two columns. That means we're doing multivariable regression. And in a stat class, we usually don't teach that because of the fact that we're usually not all using Excel at the same time. I am probably going to try to change that starting next year, though. All right, so I went ahead and had it do my output here at a certain place. And if you see, I'll zoom in here. We have a negative number associated with the runs allowed, and a positive numbers that's associated with the runs scored. Okay, that makes sense. If you're scoring runs, it should make you more likely to win. If you're allowing runs, it should make you less likely to win. So in any case, though, we are going to have this value here, and I will say that that's just going to be equal to, what do I want to call that? Maybe wins B, so it fit with other things we're doing. But here, we're going to be thinking about that as the, what was that for the runs scored? So runs scored M. And then the one underneath it will be the runs allowed M. Okay. Okay, so for our estimation there, equals, what did I say? Wins B plus runs scored M times, and then click on the runs scored, plus runs allowed M. I'll click on the runs allowed. And then it just randomly clicks some other damn place. Sorry. So it was runs allowed M times, gotta put that times in there, click there, and I hit enter. All right, so it's predicting 60.64 games. Do you ever win 0.64 of a game? Me neither. So formatting stuff here, we are going to tell it for this number to have 0 digits past the decimal, because it doesn't make sense to. And then we'll copy it and paste it to the other two positions there, right? So we're predicting that this fictional Charlotte team is going to have 61 wins, and the fictional Greensboro team will have 87 wins, and the fictional Raleigh team will, Raleigh Durham team will have 73 wins. Okay, they're all made up numbers. Don't worry too much about them. Okay. All right. Then we're going to do the predictions based on the OBP, SLG, and BA. BA stands for batting average, team-wide. SLG is slugging. and OBP is on base percentage. I'm not a sports guy. I don't really know the technicalities about any of this, but these are statistics that get collected for a team. All right, so we're going to use those to try to predict wins as well. So I'm going to make this smaller so I can get stuff in here. And now I'm going to do tools and data analysis, regression. And I'm going to leave the Y range the same, but the X range, I'm now going to highlight those three things. And because there's three columns, it will give me three variables as opposed to two columns before. And then I tell it that's okay. And then I have to tell it to put the answer down here so that it doesn't cover things up. I'll tell it okay. Okay. All right. So I'm going to say that this one is going to be the new wins B. And the one under it will be the, what was it? OBP. So OBPM. And the one under that was the SLGM. And the one under that is the batting average M. Haha, BAM. Those are my initials, by the way. So, and we'll go up here to this one in the upper, or at the top. We'll say equals new. Okay, it went ahead and suggested new wins B, and I'm going to click on that rather than hoping I can type it right. Plus OBPM times, I'll click on the OBP over there, plus SLGM times, I'll click on the SLG, plus BAM times, and I'll click on the batting average. I'll hit return. Okay. So, like before, we are formatting the cells to have nothing past the decimal because there's really no point in that. And I will copy and paste. All right. Oh, wow. The new one looks like the RDU team there is predicted to do 99 wins out of a 162 win season. So that's all right. Okay. So again, these are just random numbers that I made up here. So they don't probably make a lot of sense. But in theory, you might be able to take something like this from the current baseball season, and by having those statistics from past seasons, you might be able to make some predictions about, whether somebody's going to make the playoffs or something by doing this kind of forecasting, if you have variables that make sense for that sort of thing. So how can you tell whether they make sense? Well, if you looked at the R squared values that it was turning out, if those numbers turn out to be fairly close to 1, surely it's a pretty good prediction. But again, possibly a better way to look at it is the p-value that it gives you on that F score that comes out there. So anyway, and these are some tricks that get used. So try this out and make sure that you can do this sort of thing. All right. See you in class.